What's going on, everybody? James here from Artificial Entertainment, and welcome to AI in Unreal, the series where I show you how to be able to make effective AI inside of Unreal Engine with no code necessary. And in today's first video, we're going to be looking at the principles of AI within Unreal Engine, as well as creating a very basic structure within a behavior tree, so this way we can start building off of this later. But we're going to go over some of the very basic practices first and keep building off of it from there. So let's go ahead and dive in. So I have here a third-person template. Now this is just with an AI character. I've added some animations as well as a mesh. These are both from Mixamo. So I've added nothing when it comes to the actual AI of the character other than these two things. This is a fresh project. Now, the first thing that I do want to talk about is the things that make up AI within Unreal Engine. Now, there are a few things that make up the whole AI itself, but there's realistically three core things that are necessary to make AI functionable within AI. And we're going to talk about those three and we'll make them and talk about them as we go. And the first thing is going to be the AI controller. Now, the AI controller is more or less a pawn reference within the engine that allows you to be able to get vector data, rotation data, and it also helps calculate some of that vector rotation data and turn it into certain axis values that can be interpreted into movement for your AI. So it's also helping with calculations on top of giving you that pawn reference for location and rotation data. And to make an AI controller, it's quite easy. You just gotta right click in your content browser. We're gonna go click on Blueprint Class, and then we're gonna click all classes at the bottom here, and then we're gonna type AI controller. Now from here, we can click on this little option here, then select, and we're just gonna name this main AI controller. Now the next two pieces really do work together, but the one thing that we're going to do first is we're going to talk about the blackboard. Now, the blackboard is the brain of the AI. This is where all the information gets stored. Now, as far as what information gets stored, that's entirely up to whatever information you put into it. You can add almost any variable type inside of the blackboard, and how you change the information, well, there's a multitude of ways. Information can a lot of times be changed through tasks in a behavior tree. They can also be changed inside of the AI's controller or the blueprint itself for the character. The information inside of a blackboard can be changed in a variety of ways, but the main thing to remember is that it is the thing that stores the information that helps the control of the behavior tree. So before we go and create the behavior tree and start talking about that, let's make sure we make our blackboard. So we're just going to right click in the content browser, go to Artificial Intelligence, and click on Blackboard. And we'll go Main, AI, and then BB for Blackboard. So let's get back over to the behavior trees now. So the behavior tree is essentially I like to refer to it as the nervous system of the entire AI. As depending on whatever information is currently stored within the blackboard, it will actually change whatever is being executed on the behavior tree itself. So the blackboard or the brain sends all the information down through the body or the nervous system, and then because of whatever information is there, it's going to create a certain action, reaction, determination. So it's basically, I like to refer to it as the nervous system. And how you create a behavior tree is quite easy. We're just going to right click, go back to Artificial Intelligence, and click on Behavior Tree. And then we'll just name this main AI and then BT for behavior tree. So now we have the three main parts that we need for our AI. However, we also still need the main character blueprint as well as an animation blueprint as well. So for this, I'm going to go ahead and make a new folder real quick, and I'm just going to name it BPs. Then I'm going to double click, open this up, and then we're just going to right click, go Blueprint Class, and then click on Character. This is going to be the AI, This is going to be the AI Character BP. Now we're also going to want to make sure to make the animation blueprint as well. So I'm going to go right clicking, going to animation, and then clicking on animation blueprint. Now you're going to want to make sure to select the skeleton that you're going to be using for your AI. So for me, I have the alien soldier from Mixamo. So I'm going to go ahead and click on him and then click create and then go main AI ABP. So now what we can do is we can start linking all of these together, and then we'll go back into the animation blueprint and start setting up our animations and, kind of keep working on it from there. But the first thing we're going to want to do is we're going to double click to open up the actual character blueprint for our AI. We're going to go down to where it says mesh. On the details panel here, we're going to go down to the mesh section here under skeletal mesh. We're going to change it from none to whatever we want our AI to be. So for me, this is the alien soldier. Now, one thing I have noticed with a lot of these characters is that if you bring them down 90 degrees and then rotate them 90 degrees, they generally fit very nicely within the capsule. So this might change depending on the character that you're using, but most of the things that I've been using lately have actually followed this rule. So it's something I've discovered recently as I don't really pay attention to those values as often as I should. But moving on, what we're going to do now is we're going to click on the AI character BP self here. This is in the components tab. And then we're going to go to the details panel on the right here, and we're going to search for controller, because this is where we want to have our new controller that we made, our main AI controller. We want this to be the controller for this entire character. However, we also want to make sure to set the animation blueprint that we just made, even though there's nothing in it yet. We still want to make sure that we have this assigned to the skeleton. So under animation, with your mesh highlighted, your skeleton mesh for your character, you can go down to where it says anim class and change it from none to whatever you named your animation blueprint. So for me, this was main AI ABP. So now we have assigned the animation blueprint to the mesh. We have assigned the controller to this blueprint. So we can compile. And then we're going to go back to the AI character system here, where we have all of our controllers here. And we're going to double click, open up the controller, bring up the event graph here. And we're going to type in begin play, because we want this event begin play. Because what we're going to do is go off of the execution pin here and just type in run behavior tree. And you'll get this node here. And then the BT asset, we're just going to basically go to the drop down menu here and select on main AI BT. From here, we can just compile and save. So now, just to kind of recap really quickly, we have gone ahead and selected and made sure our animation blueprint is tied to our main blueprint that is going to be our spawnable within the world. We have also made sure that the controller is tied to this blueprint as well. The controller is then running and spawning the behavior tree on an event begin play, which means that as soon as our character enters the world, the behavior tree will be spawned. Now, by default as well, the behavior tree, as you can see here, is running main AI BP or Blackboard. So when I double click and open this up, it's automatically going to assign this blackboard. However, if you have multiple blackboards, this will not be the case. If you have multiple blackboards, you will have to assign it manually. And this is why I also like to make the blackboard first, because I have found that if you make the behavior tree first and then the blackboard, it doesn't automatically assign it. So it has something I believe to do with when you automatically create it, it's just going to search for the blackboard. So now before we start getting into the behavior tree system here, then the last thing that we just need to do is start setting up a basic animation blueprint. This is something that is necessary for any AI. So what we're going to do is double click to open up the animation blueprint for the AI. To be able to set up the animation blueprint is quite simple, but we're going to come back to the anim graph and we're going to start in the event graph instead. We're going to take these and just delete them out. We're going to add one of them back in, but it's just easier to box select and delete for me, but you can keep the on update if you would like. But the first thing we're going to do is event initialize, and we're going to look for event blueprint initialize animation, and then we're going to cast to the AI character BP class. So this is the cast to the AI character BP. And then object, we're just going to pull off of this and get owning actor. So this is all you need for this, because then we can right click on the as AI character and promote it to a variable. Then now from here, we're going to pull off of this and type movement. And then we're just going to scroll all the way down to the bottom and under variables, character, get character movement. Right click on this as well, promote it to a variable, and then just hook it up as the last thing that happens in this execution chain. You can also, if it's easier for you as well, make sure just to select no debug object selected. This way you don't get some of these weird and annoying overlays that end up happening. Now the next thing we're going to do is get that update animation. So we're going to get event blueprint update animation, and then we're going to drag out our character, so our as AI character BP, and then we're just going to hold control to be able to get the getter node, right click, and then convert to a validated get. This way it'll only occur and run this so long as our character or AI is actually within the world. And off of is valid, we're just going to run off this and run a sequence. Now this sequence is going to be very simple. The first thing we're going to want to do is get our character movement. Pull off of this and get the velocity. So you can scroll all the way down and just click on get velocity. And then from here we want vector length xy. So we're going to click on vector length xy here, and then right click on the return value, promote it to a variable. And this variable is actually going to be the speed. So this is going to be the overall speed of our AI. So we'll hook this up from then 0. And then the last thing that we're going to do is we're going to take our speed, then holding control to be able to get the getter node, And then we're going to see if it's greater than a small value, something like 3 will do. And then we'll right click on the Boolean and promote it to a variable of is moving. So just to recap really quickly, as soon as our character spawns in the world, we're going to be casting to the main blueprint so we can get a reference to the blueprint as well as the character movement. As long as our character is valid within the world, it's going to be getting the speed value of our character utilizing the velocity vector length xy. And then if our speed is greater than 3, it's going to set it as is moving, basically letting us know that our character is actually moving. This is going to help us transition from our idle to our movement state. So what we're going to do is just compile and save this really quickly, and now we're going to go over to the anim graph. And we're just going to right click and go new state machine and add new state machine. And then we're just going to take this and rename this to locomotion. You can plug this right into the output pose. Now, another thing you can do if you plan on running montages, which a lot of people who are going to be doing like drawing or sheathing of weapons, you are going to want to run montages. So we are going to also add a default slot into here because you need a default slot in order to be able to run any montages. This isn't just for player characters, this also applies to AI. So now that we have our locomotion state machine, our default slot, we'll go ahead and double click and open up the locomotion. Now off of entry, we'll just pull off of here and we're going to add a state and we'll just call this one idle. Pull off of this one and we're going to add another state and we'll call this moving. Now we're just going to drag this up a little bit, connect moving back to idle, and then we're going to look at the transition rules here. So for those of you who don't know, these little icons here are the transition rules for an animation blueprint. So we want to double click on these and open them up. And then for idle to is moving, we just want to make sure that is moving is true. So we can just literally drag this up and put it right over the result here. And it'll actually just plug it in right there. And you can just go back, go from moving to idle, double click on this one. This one, you'll have to put it in, get the getter node, drag off, and we're going to get a not Boolean. So this way, what is going to happen is going to make sure if moving is not true, then we're going to go into this transition. So it's basically true, not true. And that, again, that value is only being set if our character's movement is greater than 3. And if it's moving, it's going to be as a result of something within our behavior tree. So this is just something that our behavior tree is setting off and our animation blueprint is just doing whatever it tells it to do. Now we'll just go ahead and double click on idle here, and we'll just put an idle into the slot here. And then we'll go back to the moving state, and we'll start off with a simple walking state. We are going to end up making a blend space, but for right now, we'll start off with a simple walking state. We'll compile and save. So now as you can see, our character has a bit of more of a breathing idle motion, and if we go back to our actual blueprint here, it'll open up in the full blueprint editor. Sometimes if you don't have code inside of your blueprint, it'll eventually compile it into a non-code blueprint, which isn't really accurate, but it happens. But as you can see, that now we have that nice breathing motion to our character, so which means our animation blueprint is working beautifully. So now what we can do though is we can start creating the last piece we'll need in order to be able to actually have our AI do things. And this is called a nav mesh. A nav mesh is essentially just a quick calculation over the terrain that you set to be able to give a rough estimate as to where the AI is going to be able to move. However, it's not necessarily a rough estimate because if it's not calculated within the nav mesh, your character will not be able to move there. And a visual explanation is always best, so we're going to go up to the place actors here. Under search classes, we're going to type in nav, and you'll see nav mesh bounds volume. So we're going to drag this into our scene here, and then we're going to scale it so this way it is going to be across our entire scene here just like this. Now you can make it a little bit bigger than your level, but I don't recommend going too far. Now once you have it relatively sized, you can go ahead and press P on your keyboard, and as you can see, everything gets this nice green overlay. This lets me know where the AI is going to be able to walk and where they're not going to be able to walk. One issue you might notice here is that there is a bit of a gap here. This part is able to be walkable, this part is walkable, however the connection point between them is not. This is easily fixable, however something to be careful with, just by scaling it up a slight bit until you get that walkway. Now this means he'll be able to walk up to the top, but he won't be able to access this. Now this is probably ideal if you're doing testing in the third-person template, as this and these are all the same height. So it might register that this is technically a walkable location, but there's no path to it. So it's something just to be mindful of when you're making your nav meshes. And there's a ton of more information on nav meshes that I'm going to be putting out in a separate video, but today we're just talking about the basics and fundamentals of creating the start of the AI. So now that we have our nav mesh and we have all of our main components that we need, now we can start doing the fun stuff. So we're going to open up our behavior tree and we're going to start giving our AI some things to do. Now I want to talk a little bit about what the different components of the behavior tree are though. So off of the root, this is what's going to fire off every single time the behavior tree launches. Once you pull off of this little gray box here, as you can see it highlights, you can just click and drag off. Now that we have three different things that are referred to as composites. We have a selector, a sequence, and a simple parallel. The selector is going to basically choose the first child that doesn't fail. So if I put a wait task here and a wait task here, it's going to execute this over and over and over again unless it fails for whatever reason. I don't want to complicate it too much, but that's what a selector does. It's just basically going to select the first child that doesn't fail, and once it does fail, it's going to move to the next. Now, the next option is a sequence. A sequence is basically just like it is inside of a blueprint, where it's going to run each child one time. So if it'll run wait 5 seconds, and then it'll run this wait 5 seconds. If there's nowhere else for it to go, it'll just run itself again. So this is the thing with the sequence, is that it's going to run these parts over and over and over again and just keep going down. There's nothing that's going to stop it and just force it to run this side. So if you want something to run a specific branch, like a main execution branch, you always want to start with a selector. Now, I do want to talk a little bit about the simple parallels. Now, these can be a little complicated, so we are going to be going over these later on, but I just want to kind of give a brief understanding as to what these are. So simple parallels are actually very powerful, but can also be very dangerous. What they are is allow you to be able to run two different tasks. Now, within the behavior tree, you have your composites, which is mainly all of what I just showed you, but you also have tasks that you can run as well. So the simple parallel can run one task and one composite. A task is a list of things that it can look for. So a wait cooldown, which is what you saw me put in there, is a reference of a task. A move to or a play animation, play sound, and you can even make your own custom tasks as well. But these are the tasks list, and these are all that can be run off of this this purple node. Now off of this one, you can actually run composites like another simple parallel, and you can just keep going crazy with this, but this is where it gets dangerous, okay? So the simple parallel is going to run this task while it also runs this task. So if you have a play animation, for example, running off of a simple parallel, whatever the duration of that animation is going to be the duration that it runs this chain. Once it stops, if the animation does not start running again, like if it's not forced to run itself again, then what's going to happen is none of this is going to be executing. And it's also going to stop it in the middle of it. So you want to make sure that whatever you're setting off the simple parallel and the task itself that's going to be executing it at the same time, because that's why it's called a simple parallel, because it's running the task and the either task or composite in unison. Once one is running, the other is running as well. If one is not running, the other is not running. So again, these can be a little bit complex, but I just wanted to give a base understanding. I didn't want to just miss over it because I wanted to really discuss the entirety of what these composites are. So let's start looking at how to be able to make certain information within our behavior tree. Now, again, all information is stored within the Blackboard, and the easy way to be able to go between the behavior tree and Blackboard is actually through these tabs up here. So we can go and just click on Blackboard here. Now you can see we have access to the key options as well as the details panel for those keys. So for example, if I go and click on self actor here, this is referred to as an object type, but it's an object type of actor. So this is going to be the reference of self for the AI itself. Now, what we're going to do is we're going to set up a simple roam around, find a location, sort of patrol pattern, right? But in order to be able to set any sort of patrol or move to anything, you have to set location data. And this is where, as I had said earlier, how you can set as many value types as you want within the Blackboard, but then you just have to change those values based off of certain conditions. So what we're going to do is under Blackboard, we're going to go new key, and then we're going to click on vector. And we're just going to take this and name this patrol location. So now that we have patrol location, we need a way to be able to set the patrol location as well. Now the easiest way to do this is to go back to the behavior tree, and then you're going to see this option up here that says new task. So we're going to click on this, and it's automatically going to bring up this screen and to let you name it. So for this, we're just going to name this find patrol location. Now, once you hit enter, it's going to bring up this graph here. So what we're going to do is go to functions, override. So this is on the blueprint section here. And then we're going to click on receive execute AI. And then from here, what we can do is start giving it some information to work off of. So we're going to pull off of the execution pin here, and we're going to go get random location and navigatable radius. And then what we're going to do is get the controlled pawn, get actor location, and we're going to plug this in as the origin. And then the radius, this is how far it is going to go to be able to get that location. So we'll go for something like 650 for right now. Now, you don't have to worry about the nav data or the filter class. From here, all we need to do is pull off of this execution pin here, and this is where we're going to set that Blackboard information for that vector key that we made. We can just type in set value as vector. So set Blackboard value as vector. Now you can see we have a vector value and a key variable here that's a struct. So what we're going to do is we're going to take this random location, plug it into this value, right click on this key and promote it to a variable. And we're just going to name this BB key, just standing for Blackboard key. But we also want to make sure we make this instance editable or public, so we can make sure that we can actually access this inside of the behavior tree. So we're going to make sure to make that public. And the last thing, and this is something you want to make sure to do at the end of every single task that you make inside of a behavior tree. Because if you don't, it's just going to run it on an endless loop because it won't know when to finish it. So we want to make sure at the end of this, we're going to pull off and run with a finish execute. Because this will tell it that once you've done this, that's when this task is ending and move on to the next thing. So now that we have a way to be able to get a patrol location, we're going to compile, save, and go back to our main AI behavior tree. Now, as I had stated before, off of the root, you always want to use a selector. So we're just going to type in and get a selector really quickly. And then off of this selector, we're going to get another selector. Now, I know it seems redundant, but realistically, a behavior tree is comprised of multiple different selectors, sequences, and simple parallels to be able to actually create the entire functionality. So this is essentially going to be our patrol behavior. So this is going to be the main selector that chooses between all the different behavior types, and this is going to be the first selector for our behavior type of patrol behavior. So I like to name them and kind of keep it organized. But we're going to take it and put it as patrol behavior. Now, what we're going to do off of this selector is we're going to pull off and run a sequence here. Now, this sequence, we also want to put a decorator on this, but we'll do that in just a moment. First, I'm going to show you guys how to be able to use that task that we just made. So what we're going to do off of the sequence, we're just going to pull off and we're going to find patrol location. Now, what this is going to do is find a patrol location. So it's going to find a location. Now, in order to be able to set the value to be able to use it within your behavior tree, you have to make sure to have the actual task highlighted and then go up to the into the details panel under default Blackboard key. Make sure to change this to patrol location. This way, it'll find a location and set that location as the patrol location within the behavior tree. So again, you're setting information that is just stored types of information within the Blackboard, but you're changing it from a different source. So we're going to run and find this, and then we're just going to run a wait task. And we don't have to set it to a very long wait. We can set this to 0.5. I just like to do these as a buffer because it just makes things run a little smoother. And then from here, we're just going to drag off of this sequence and type in move to. So these are all very simple basic nodes where this is the task that we created. We just pulled off of the sequence and hooked it up. And then adding just pulling off and typing out wait under the tasks list allows us to be able to run buffers. And this allows us to be able to, whenever we're setting information, also give it a moment before it actually tries to do something with this information. Now, the main reason for this is because while right now, while you're in your viewport, it might not look like it's running that fast. However, once you do the final packaging for your game, everything is going to run so much faster. So usually what I like to do is put like 0.5 second buffers in between when information is being set and then being used directly after. This way, once the game is actually in develop or out of development and into like the public product, you're not going to have any weird issues with the way that the information is being set within the behavior tree. So now what we're going to do though is with this move to, we're just going to go and under Blackboard under the details panel, we're going to change this Blackboard key from self actor to patrol location. Because what this is going to do is we're setting that patrol location, giving it a little bit of a buffer, and then telling it we want to move to that location. However, what we also want to do is, like I said, we want to make it so that way there's a bit of a condition on this so it doesn't run it over and over again. So what we can do is off of this, we can right click at the top here, and we're going to go to add decorator, and this one is going to be a cooldown. Now, as you can see, there are a ton of decorators. We have blackboard conditions, we have composites, conditional loops, a whole bunch of stuff that we can mess around with here. But for this one, we're just going to do a simple cooldown. And then, as you can see, it does make the node a little bit bigger, so we can go ahead and just kind of fix our strings a little bit. And then the cooldown, I like to set it to right around 20 seconds. So this way it'll go to a location and then do something else, but this is where we're going to tell it what to do now. So one thing I like to do with patrol behaviors is actually also add in sort of an idolized action. So like when they're at the location, what do they do next, right? Now again, because the selector is going to select the first child that doesn't fail, which as we can see here, that this is 0, as you can look at the little numbers at the top here, this is 1, this is 2, and 3. So it's going to go through this branch first. So long as this branch doesn't fail, it'll always go to this. However, once it does fail, what we can do is run another selector, and we'll pull this down a little bit, and we're just going to name this random idle behavior. Now, there is no randomizer already built within Unreal Engine. However, it's very easy to make one. So that's what I'm going to show you guys now. So we learned how to be able to make tasks. Now we're going to learn how to be able to make decorators. Now again, tasks can be used for a variety of things, and I'm going to show you a lot you guys can do with tasks, but you can call custom events, you can do whatever you want with those tasks. It's just setting of information in some way or executing some function. So don't think that they're restricted to just getting information. You can do a whole bunch of stuff with that. But again, we're going to cover that later. And decorators are just flow control. And to be able to create a decorator that's like a nice randomizer, what we're going to do is go up to the top where it says new decorator. Click on that. And then we're just going to go random chance decorate. Now, what we're going to do is we're going to go to the functions tab, go to override, and we're going to go perform condition check AI. This is going to give us a nice Boolean value that we can use over here to be able to just get a simple true or false statement based off of whatever we set it as. And for this one, we're going to need a random float, and we want the random float in range. What we're going to do is we're going to keep the min to 0, set the max to 1, take the return value and see if it's less or equal to a certain value. Because this is what we can do is we can take this, right click, promote to a variable, and just name it random chance percentage. And then we're just going to take this, kind of clean it up a little bit, and we'll take this Boolean value and plug this into here. Because what this is going to do is that between 0 and 1, we can take that random chance percentage, and if we just use a 0.10 percentile, so like 0.1, 0.2, 0.3, 0.4, what this is going to mean is 10%, 20%, 30%, 40%. You can also go between 0 and 100 if you would like, but 0 and 1 also work as well. You can just use a simple decimal system to make it so that way it's going to work the same way. But now that we have this, we can go ahead and just compile and save, and that is all. Decorators do not need the end tasks, because these are just basically conditions to set whether or not something can or cannot happen on the behavior tree. As I said before, the blackboard's information is going to set all of this, as well as some information within the decorators. So what we're going to do now is under the random idle behavior, we're just going to right click, go add decorator, and then we're going to click on random chance decorator down here. Now, I almost forgot something though. So we're going to go back to random chance decorator though, because we want to make sure to actually set this public, because we want to edit this value. So we're going to compile and save, and now we can set this to something, let's say 0.7. So this way, 0.7%, which means it's a 70% chance that this will execute. However, we can then go off and do a play animation, and we'll put another one over here as well. So it'll play animation. Now again, a selector is just going to select the first child that doesn't fail. If one does succeed and then end, it's going to go back and kind of run off in another direction. So that's the thing that's great, is that when trying to create random idle behaviors and you just wanted to choose between one of the two, use a selector. Use the randomized chance decorator, and this way it'll just choose one. If this one fails, it'll go and do this one, because we're also going to add the random chance decorator to both of these as well. Because what this does is it helps create a higher randomization, because it has to run through the random decorator twice. And realistically, the more times you have to run through a random generator to be able to get a very specific value, the lower the chances that value were going to be obtained. So now what we can do is just go ahead and just pick a couple animations. I've got one here with, talking on a cell phone, and another one called a dwarf idol. I don't know why it's called a dwarf idol. He's realistically, he's just kind of like swatting away flies. I don't know. I guess they're saying dwarfs smell. Who knows? But anyway, so now what we're going to do though is because we have the selector here selecting one of these two, if any of these fail, we need to give it a buffer. So off of the patrol behavior, we're just going to add a wait task. And I like to set these to around 2.5 seconds, nothing large, because every time it ends, it's going to try to execute one of these two. So this wait is going to be however long it takes to be able to get back into one of these, which is why I like to set the cooldown lock a little higher on these, so this way it gives it time to be able to actually choose something. However, we also need to make sure to set this random chance percentage. So I'm going to set this one to a 0.4 and this one to a 0.7. So this should mean that there's going to be a higher percentage chance that the dwarf idol will be playing rather than the talking on cell phone. So what we just did, just to show you guys, is that we just created a simple sequence where it's finding a patrol location using that task that we made, waiting a second, and then moving to that location. The thing about sequences is that these are going to stop, so once it's not going to move forward until the move to has been finished. Once the move to is finished, it's going to cooldown lock itself for 20 seconds and then execute the next branch, which is going to be playing of one of these two idle animations with a simple random chance decorator. We're just waiting for 2.5 seconds and then kind of recycling all over again. So let's take a look and see if it works. So we'll go ahead and minimize this really quickly. And then we're going to go to our blueprints here and take our AI character and just drag him into the world. Now, if we go ahead and hit play, you'll see he's walking around. However, his speed is way too fast. So we'll just go ahead and slow that down really quickly so we can actually see him walking around versus looking like he's on meth. So I'm just going to go max walk speed. And you want to make sure to be on character movement when doing this, not like what I was doing. And I'm going to set this to a value, I think it was 175, I think it's a value for the maximum walks, but I don't remember 100%. Yeah, that looks proper. But if I go and look at the behavior tree, just bring that up really quickly so you guys can see. It's going through the wait for 2.5 seconds, and then it's playing one of these two. However, it has a chance to not actually go through. So if I stop this really quickly, and then click play again, it's going to go move to... but the random chance percentages are high. So if I set these to 0.1 all the way around, and then click on save, the second it moves to its destination, you can now see that it's completely failing the random chance because it's set to a very small value. It's not really going to be able to hit that very easily. So if I take the random chance percentage, set this to maybe like 0.3, and then 0.4, so set a lower value on whether or not it can trigger at all and set a higher value between playing one of the two animations. It's really just all about playing with the percentiles, but as you can see, it's definitely randomizing and choosing and trying to get a number. If it doesn't get a number within that percentage, it's just going to keep cycling back and he'll just kind of stay there for a moment. The thing that's great about this system is that if you spawn in multiple of these, each one is going to choose a different randomized number. So which means that you might have 16 of them inside of your level, but only one of them is actually going to be talking on their cell phone, and maybe a couple of them. But now we have a very simple patrol location made. You guys have a basic understanding of how to be able to make your own decorators and tasks. So in the next video, we're going to be going over a lot more detail about tasks, decorators, and we're also going to be taking a look at the perception system utilizing the EQS. So I hope you guys are excited. That video is going to be coming out soon. That's all for today, and as always, stay animated.